August 2nd, 2025. At exactly 1:25 p.m., a tiny drone was advancing to blow up a bridge built with massive concrete supports. The bridge was a critical Russian logistics point on the bend of the Tsata River overlooking the Bryansk Oblast, but it was almost impossible to blow up the bridge with only 500,000 grams of explosives. Nevertheless, in a few moments, the bridge would be blown up with almost 250 tons of TNT. This inexpensive drone was operating without any assistance or fire support. Because the Russians had positioned nearly 30 TM-62 anti-tank mines under the bridge to block Ukrainian advances. If Russian forces received an order to retreat, they were prepared to blow up the Ukrainian tanks and armored vehicles approaching the bridge with a single button press. If the drone could reach these explosives in a single strike, the Russian convoy's passage would be cut off and Ukrainian troops would survive. The target was clear but also risky. The operation required great skill. Because the Russians had set up nets and traps to protect the bridge, at 1:25 p.m., the signal from the drone codenamed Buzzer 01 appeared on the frontline monitors, revealing numerous anti-tank mines chained together with cables in the middle of the bridge. The Ukrainian headquarters made a counter-decision within 10 minutes. The Ukrainians would pull the pins before the Russians could. The operation began as soon as the mines on the bridge were discovered. The buzzer-coded FPV reconnaissance drone reported that it had detected the same magnetic traces as the explosive device array on the old concrete arch bridge over the Tsata River. When the operators transmitted the data to the headquarters of the 1st Separate Counter-Terrorism Brigade, the routine patrol flight was transformed into a planned demolition mission within an hour. This was because it became clear that Russian field units had left exactly 30 TM-62 anti-tank mines on the bridge deck. This proved that even the Russians considered the bridge critical for the security of the Moscow-Klincy-Unica supply line. Normally used as terrain obstacles, the TM-62 mines had been buried 6 meters apart along the beamline to direct the explosive wave into the concrete. The mines were connected in a cascade so that they would be triggered simultaneously. These Soviet-made mines, with steel bodies carrying 7 to 8 kilograms of TNT, were powerful enough to tear the underside of a tank apart. Under normal conditions, these mines would be activated either by a mechanical triggering system or by remote detonation. While examining this arrangement, the brigade intelligence officer concluded that the Russian side had not yet fired, but would resort to the dynamite bridge tactic when retreating, if necessary. And the operation plan evolved into the idea of using mines to destroy the mines. The Russian explosive set would remain stationary, while the Ukrainian side would use the Vampir FPV unmanned aerial vehicle as a remote detonation trigger. The TM-62 contains 7 to 8 kilograms of TNT in its body, and the pressure on the fusion element on top detonates the mine. When the drone hit with precision, it would create a shock reaction powerful enough to trigger one of the TM-62 anti-tank mines inside the steel console holding the bridge. The plan was to proceed in this manner. This way, they would not only turn the enemy's ammunition against them, but also avoid the need to transport tons of additional TNT to destroy the massive concrete beams beneath the bridge. Ukraine has prepared a Vampir drone for this mission. The first task in this challenging mission was to break the radio frequency barrier on the bridge. This was because the Russian electronic warfare team was operating a frequency jammer on the 500 MHz band, disrupting the standard 5.8 GHz FPV signal. To overcome this, the Vampir drone's command link was switched to a 900 MHz military LoRa-based system. Each Vampir drone could carry a 2-kilogram composite body, a 10-inch propeller, a 6S lithium battery, and a 1.8 kilogram warhead. It was calculated that when the plasticine prepared with a mold press in the warhead hit the pressure plug cone on the TM-62, it would push the TNT inside the mine above the heat threshold. The warhead casing was designed to trigger the explosive rather than produce excessive shrapnel. Thus, the 30 TM-62 mines gathered on the bridge would detonate in a chain reaction at the same moment, generating a blast wave equivalent to several tons of TNT, which would sever 2 central beams and 1 side support. Because the Russian infantry unit defending the bridge until the explosion kept the minefield information secret, only a few machine gun nests were visible during routine patrols. For this reason, the drone operators conducted 3 additional reconnaissance flights during the preparation phase. The operators wanted to be absolutely certain. Thermal cameras confirmed the MG3 posts on both sides of the bridge. They determined that the shift change interval was 15 minutes, that the jammer vehicle was waiting 200 meters north behind some bushes, and that the TM62 mines were connected to each other with Menatep analog wire detonators. Once the chain of explosives was clear, the Vampir team decided to conduct drone surveillance of the north and south ends of the bridge. The MG3 post at the north exit would first be tracked thermally, and when the drone camera spotted the weapon being raised, a bat-coated empty FPV would be sent to distract it. When the machine gun fire was directed at the fake target, the real Vampir would glide under the beams like a fishing net from a low altitude. In other words, the Vampir drone that would carry out the actual attack would also be protected in a sense. Meanwhile, the fake FPV with the bat code was flying in a straight line, 35 meters above the river toward the northern MG3 position. The engine noise was deliberately kept at maximum speed. The aim was to trigger the machine gunner's sudden reflex to fire. Sure enough, when the first short line of the MG3 barrel flash appeared on the low-resolution camera, the pilot of Vampir 1 aimed the nose camera at the beam under the belt, despite the pixelated image on the screen. The drone operator lowered the altitude to 6.3 meters, and the speedometer showed 58 kilometers. At this moment, the jammer vehicle burst out white noise on the 500 MHz band, and the bat screen began to flicker. However, since the real Vampir remained on the LoRa 900 MHz carrier, the telemetry was flowing without error. The pilot did not correct the course or altitude again. This was because the autopilot vector lock was connected to the TM62 position line. The Vampir drone that was to carry out the attack simultaneously dove toward the south leg. The operator was busy maintaining gyroscope-based horizontal stability on the edge of the bridge deck, facing the water. In the live video feed from the drone, the round pressure plates of the mines appeared as ghostly spots in the water's reflection. The black cable connecting the explosive chain stretched toward the center of the bridge like a tree branch. When the Vampir drone reached the target altitude, the sponge buffer beam under the nose touched the concrete. It absorbed the impact shock and seated the plasticine cone precisely on the TM62 pressure plate. The pilot issued the fire command, and the cone deflected the mine cover at a 40-degree angle, delivering a thermal blast to the internal TNT. The mine detonated with full force, instead of the supposed staged explosion within seconds. This explosion set off 29 mines standing side by side. The charges, buried at 6-meter intervals, detonated in succession with a half-second delay. The pressure wave, equivalent to 8 tons of TNT, first pushed the bridge deck upward, then broke the main girder and tore the 2 side legs from the base. The explosion spray sent a mushroom cloud toward the water surface. The 22-meter-long central section of the bridge's concrete suddenly turned to red and black dust. At the same time, the southern part of the Vampir's hull was blown to pieces by the shockwave, but the operation had achieved its objective. The shockwave spread through the surrounding area at a speed of 1,380 meters per second. It swept away the foggy moisture covering the river. The Russian sniper, at the MG3 position, likely collapsed behind the trench. The block cover of the diesel generator inside the mixer vehicle was shattered by the impact. The radio noise suddenly stopped. As soon as the operator saw the signal loss on the monitor, the command algorithm calculating the post-explosion weight distribution confirmed that the bridge could not be saved. This was because each of the 2 main arches supporting the middle girder was made of 600-millimeter thick pre-stressed concrete. The chain reaction explosion split this mass into 5 pieces. The heaviest block weighed 48 tons. This block was submerged in the waterbed. The floating crane capacity available to the Russian field engineers was 25 tons. Therefore, the likelihood of lifting and repairing it was virtually zero. This old crossing was the only high-capacity bridge on the Bryansk-Unecha route. Before the demolition report could be forwarded to Central Command, the Highway Supply Battalion Baza 2 convoy received an order to change its route. This was because 8 fuel tankers and 4 Obart 122mm ammunition trucks were only 11 kilometers away from the bridge. If the bridge had been blown up 15 to 20 minutes, or at most half an hour later, the situation could have turned into a disaster for Russia. The logistics center diverted the convoy to the Trubchevsk road with an emergency plan. But that road was of poor quality and had a 20-ton weight limit. The tankers were not allowed to pass, and as a result, the diesel fuel and rocket shells destined for the front line were delayed by 24 hours. 3 hours after the destruction, Russian Bryansk troops watched photos of the bridge and spread propaganda that the Ukrainians had blown up the bridge with several tons of TNT. But in reality, the total amount of explosives used was 3.6 kilograms of plastid, and the rest was 30 TM-62s buried by the Russians. This detail deepened the impact on the psychological front. Because the rear mine preparation had turned against itself, the entire crossing could be destroyed with a single button. The core feature of the Vampir drone came to the fore here. With its 4-motor X configuration, carbon fiber frame, 10-inch propellers, and 6S LiPo battery, it can fly at a constant speed of 60 to 70 kilometers per hour, over a range of 6 kilometers in just 10 minutes. The LoRa 900 MHz telemetry system is resistant to jamming and transmits analog L-band video of sufficient quality to identify target lines despite noise. The drone's warhead is modular. It can be equipped with either a penetrating EFP or HE shrapnel warhead as required. For this operation to destroy the bridge in Bryansk, a trigger warhead was selected for the drone. In other words, the real explosive was the enemy's ammunition. 12 hours after the destruction, when a Russian engineering company intended to install a PMP pontoon set on the bridge wreckage, Ukraine's wide-body kamikaze drone, codenamed Shrike, took off. This drone drove away any vehicle approaching the bridge pier. This prevented any attempts to rescue the bridge pier. As a result, the main artery of the Bryansk supply route was cut off for at least 6 weeks. This was because the 46-ton concrete deck, broken into pieces, was blocking the river and leaving no clear passage for temporary pontoons. According to field signal tracking, Russian Supply Command immediately began using the Sevsk-Kursk route the next day. This route adds 90 kilometers of detours and exposes the route to HIMARS threats along the Vovcha swamp. The bridge demolition also opened up debate about Russian mine doctrine. This is because storing TM-62 chains as traps, rather than for defense, is now considered risky. Moscow reports suggest that drone nets should be deployed over mine loads. However, this also increases logistical and time costs. The message from the drone front is clear. A 3 to 4 kilogram Vampir took down a heavy crossing with a single strike, carrying 30 mines. The operation lasted 18 minutes, from taxiing to detonation. The cost to the Russian side will be a logistical setback lasting days, perhaps weeks. Before the bridge debris had even cooled, the intelligence unit of the 1st Separate Counterterrorism Brigade fed the telemetry data collected from the field into the feedback loop. The analysis unit's initial finding was a 0.11 second phase difference between the explosion time of the TM-62 Cascade and the Vampir warhead delay. This interval caused the 3 mines at the eastern end of the chain to detonate partially delayed, enabling the beam to break cleanly, but shifting the angle of the concrete blocks falling into the water by 5 to 6 degrees from the anticipated trajectory. Since the operational objective of the mission remained unchanged, tactical success was fully acknowledged, but the brigade commander decided to add an additional impact pinhole to the triggerhead in the next operation to reduce the phase difference to 0.04 seconds. This would improve the symmetry of the chain explosion and completely sever the bridge pier from its base, eliminating any chance of it floating away. The same report also recorded Russian countermeasures. 2 RB-341V Lear-3 electronic warfare trucks withdrawn from the Bryansk-Gomel lines were deployed to the Unecha region. The task of these vehicles was to scan LoRa 900 MHz packets and feed data to the Vampir telemetry system. This would have given the Russians a step ahead in instantly distinguishing between real and fake drones. But it was too late, and the bridge had already been destroyed. This meant that the efforts in the region were now meaningless. The Ukrainian side, however, continued its preparations for such operations unabated. Despite the brigade's commanding officer sweeping the Lear-3's LoRa channel, they loaded a frequency-hopping FHSS update onto the Vampir. The third finding was the ripple effect of the bridge disruption on the logistics chain. Since Russian ammunition convoys were forced to detour via Sevsk, the delivery of 122mm rockets to the front line, which normally took 2 days, dropped to 4 days. In this gap, Ukrainian artillery batteries had no difficulty in detecting Russian Grad launchers under radar contract fire. 4 BM-21 carriers were destroyed within just 48 hours. Field reports also showed that the need for diesel tankers had risen by 18% due to the increased distance, which in turn pushed back the Kuban refinery's delivery schedule. This domino effect confirmed the critical passage equals battery silencing formula for the brigade planners. A new target list was prepared for the Vampir line: Navia Station Viaduct, Trubchevsk Narrow Arch Bridge, Polpino Ro-Ro Ramp. All these locations could become targets for Vampir drones in Ukraine's next offensive operation. Meanwhile, drone production workshop capacity was also mentioned in the report. The secret facility produces 12 bodies per day, with 70% of the parts made from 3D printed plastic, carbon fiber frames, and engines sourced from Shenzhen, while the batteries are assembled in Lviv. A complete Vampir package including the head costs $3,800. This price is 1/3 the cost of a tank mine. From a strategic point of view, the loss of the Bryansk crossing does not yet change the frontline map, but it will delay the summer-autumn resupply schedule of Russian troops. This is because any new concrete bridge construction requires 18 months. The temporary pontoon bridge is at risk with every rainfall. During this period, the brigade aims to target secondary crossings with a mix of Vampir Shrike drones, forcing ground-to-air missile resupply to be transported on T-72 chassis instead of trains. As far as we understand, the destruction of bridges in Bryansk was more than just a tactic. It showed how cheap FPV drone explosive combinations could destroy Russian logistics architecture overnight. Now, the same technique of turning synthetic mines against themselves is on the list of plans to be tested on Navlia and Trubchevsk. Lear 3's frequency hunt is being updated. Vampir software is being set up to stay one step ahead, and a new rule for paralyzing major arteries on a small budget is being added to the frontline playbook. This means that all the main logistics arteries within Russia's own borders are actually at risk of drone attacks by the Ukrainian army. In short, the bridge blown up in Bryansk may only be the beginning. In the coming days, we may witness many more bridge demolitions on the front lines. Thank you for watching.